Welcome to Unit 6, Inference for Categorical Data on Proportions. In this video, we're going to be talking about Topic 6.8, Confidence Intervals for the difference of two proportions. All right, so the easiest way to explain this to you is to start off with an example. I think it'll make a lot more sense. All right, so consider the following question. What is the difference between the proportion of teenage girls that do their homework every night and the proportion of teenage boys that do their homework every night? Well, I have no idea what the difference is. Maybe it's a big difference, like 20% of girls do their homework more than boys. Maybe there's no difference. Maybe it's a pretty small difference. I just have no idea. So the idea here is that we're clearly looking at two different populations. Boys, girls, teenage boys. But we are looking at the same proportion. The proportion we're looking at is the proportion of them that do their homework. But we're comparing these two different populations of boys and girls. So what are we dealing with here? Okay, so after we, analyze that very simple question, we have to make sure that we are examining the same categorical variable of does a teen do their homework every night, yes or no? So even though we are looking at two populations, we're still asking each population the same question, do you do your homework every night? But we are comparing boys versus girls. That's super important to understand. So we are looking at two different population proportions, but all we want to find is the difference. However, you can't find a difference without two values. So we are looking for one number, the difference. But the problem is, to get a difference, you need two numbers. So you'll notice here that what I'm going to do in this problem is I'm going to explore what is the difference between the proportion of girls that do their homework every night and boys that do their homework every night. Now, it's super important that you use these little subscripts, girls and boys, so we distinguish between the two different proportions. One for girls, one for boys. Now, you could do it in the other order, boys minus girls, but keep in mind that the order of subtraction does matter, so you would get the same value, but just positive or negative. So I'm going to look at this in girls minus boys. All right, so the idea here is that the true difference between these two population proportions is either going to be positive. Now, think about this for a second. If this is positive, if this difference is positive, it means the girls were bigger. That means a larger proportion of girls do their homework. Or the difference could be negative. Now, if it's negative, that means that the back value, the proportion of boys that do their homework, is bigger. That'll produce a negative difference. Or the difference could even be zero. Now, if the difference is zero, it means that there is no difference between the boys and girls and that the two proportions are exactly the same. Hence, no difference, meaning a difference of zero if you were to subtract them. So, I'm trying to answer this question. What's the difference between the proportion of girls and boys that do their homework every night? And there's a lot of analysis that goes into that simple question. And the idea is I'm looking for a difference. And that difference is going to involve two different numbers, girls and boys. And I have to understand that that difference could be one of three things, positive, negative, zero, and I have to know what each of those possibilities represents. All right, so there's one thing is for sure. If we're going to find out what the difference is, we need to start off with a sample from each population. There is no way I have time to ask every single girl in the world, every single boy in the world if they do their homework. There's no way I'm going to literally be able to find the actual true difference. So I'm going to have to start off with some samples. All right, so let's get some sample proportions. I'm going to look at a random sample of 230 teenage girls, and 184 of them said yes, they do their homework every night. That is a sample proportion, so notice now I'm putting that little hat right here because this is signifying that we have a sample proportion of 0.80 for the girls. 80% of the girls in my sample did their homework. Then I'm going to get a sample of 250 boys, and of those 250 boys, 180 said yes, they do their homework every night. And that is a sample proportion. So again, the little hat there for the sample proportion is 0.72. So the difference in my observed samples is very simple to do. For the girls, it was 0.80. For the boys, it was 0.72. That's a difference of 8%. So in my two samples, I saw that the girls had a higher proportion, 8% higher than the boys in terms of doing their homework. All right, well, listen, guys. This is just one sample difference. Or let me rephrase that. This is just one difference between two samples. And boy, I hope you've learned one thing in the last lot of units is that samples are going to vary. So this is just one difference that's possible, but boy, oh boy, if I get any other two samples, one of boys, one of girls, I could potentially get a different difference. So we do have to consider, of course, a sampling distribution. Now remember, a sampling distribution will show you what the true difference is between all possible samples, and it will show you how they deviate. Now, we know that the mean of all possible differences between boys and girls will be the true difference for girls minus the true difference from boys. So if I put a little G there for girls and a little B there for boys. So the idea is that my sample came back with an 8% difference. But the true difference would literally be the mean of all possible differences. And again, I also know that everything varies, so there is a standard deviation for those differences as well. And we learned this formula all the way back in Unit 5 over sampling distributions, but the formula is the square root of the first proportion for the first population times the opposite of that divided by the sample size plus the other proportion from the other population times the opposite of that proportion divided by the sample size. Now, the big issue here is that this sampling distribution does exist, but without me knowing the true proportion of girls that do their homework and the true proportion of boys that do their homework, I cannot build this sampling distribution. But you need to understand that somewhere out there is this very normal sampling distribution centered at the true difference between the proportion of girls and the proportion of boys that do their homework. This does exist. I just don't know what it is. Now, let me just take one quick time out. You knew this was probably coming. I need to check my conditions. Both samples have to be random to avoid bias. Both samples have to be under 10% of all teenage girls and under 10% of all teenage boys. And the two samples, each of them needs to have 10 or more kids that do their homework and 10 or more kids that don't do their homework so that the sampling distribution can be normal. All right, now that we get all that out of the way, here's the deal. This sampling distribution does exist. I just can't make it because I don't know the truths. But my difference of 0.08, it falls on here somewhere. Now, I don't know where, right? Does it fall close to the true difference? Does it fall a little high, a little low? I don't know. But here's the deal, guys. We know, for example, that 95% of samples are in the middle. That's between negative 1.96 and positive 1.96, right? That is my Z star that we have learned, 1.96 for 95% confident. So the deal is that I'm pretty confident. In fact, I'm 95% confident that my difference of 8% falls somewhere in the middle, right? It would be very unlikely to be extremely high or very unlikely to be extremely low. Yes, it is possible, but not likely. That would be significant. So I truly believe that my sample difference is somewhere really, really close to the truth. All right, so we do not know the true difference in the proportion of boys and girls, but we can be 95% confident that the difference between our sample proportions should be so close to the true difference between the population proportions that if we wrap an interval around our sample differences, then we will contain the truth. So let me go back to this picture real quick, right? The idea is I don't know where my sample is. I really don't. But I'm very confident it's somewhere in the middle where most differences fall. So let's just say it falls right here. Let's just say my 0.8 was a little bit on the high end. Well, if I wrap an interval around it, going down and going up, the truth right here does get caught in my interval. And the idea is very simple. We've already learned this as well, so this should make sense to you, is that as long as my difference falls anywhere in the center, then when I build that interval around it, I will capture the true proportion with that level of confidence. So we really do need to consider that critical Z value that is based on how confident we want to be. We've been doing these a while. Hopefully you remember how to find these. For 95% confidence, that's 1.96. For 98% confident, that's 2.3263. And then for 99% confident, that's 2.5758. If you completely are blanking on how to get those numbers, let's just walk you through 95% real quick. if we're 95% confident in the middle, sorry for a very bad normal model there, then that means that there's 5% of samples that are deemed significant. But that gets split up, 2.5 at the bottom, or excuse me, 2.5 at the top, 2.5 at the bottom. So to get the z-scores that represent that middle 95%, you are going to go to invert norm on your calculator. And remember, the only thing invert norm needs you to type in is the proportion below. So it's going to want that bottom 0.025, and that will come back with the z-score of 1.96. Now, it's going to give you negative 1.96, but we know that the top 2.5% would be marked by positive 1.96. All right, so now the only thing we got to figure out is that if we're going to build this interval centered at our samples difference, we're going to go up, we're going to go down 1.96 standard deviations, right? Not so fast. Well, once again, remember the formula for standard deviation for the difference is required that you know the true proportion for boys and girls. And yeah, I don't know that. So once again, here is the formula that we learned back in Unit 5 for the standard deviation of a difference. And notice that the formula requires the true proportion. In this case, for the girls, I'm calling 1. And for the boys, I'm calling 2. But I'm sorry, don't know those numbers. So I cannot use the standard deviation formula. But have no fear, our friend standard error is here. Remember, standard error is just a twin brother standard deviation. In fact, it's the exact same formula. I just have to call it standard error, and we don't have a fancy Greek symbol for standard error. We just use SE for standard error. But the formula is exactly the same, but it uses p hat, our sample proportion for the girls, and p hat, our sample proportion for the boys, instead of the unknown true proportions of the populations. So again, we actually had the same problem occur when we dealt with confidence intervals before. We just have to use standard error in place of standard deviation. Whatever. It's not a huge deal. You'll learn in more advanced statistics classes that it's actually very, very accurate. All right. So here's what the interval looks like. Here's a basic description of the interval. First, you start with your difference. What was the difference between your two samples? Now remember, it's one number, but it takes two numbers to get that one number. Generically speaking, I'm just using 1s and 2s. In our specific problem, it was girls and boys. All right, then we're going to go up and down by, remember, this back part has its own name, the margin of error. The margin of error is your z-star, your critical z-score, and that's based on your level of confidence, times the standard error. So again, here it is same exact formula, just replacing the standard error with the formula for standard error. And guys, that's it. This should all sound very familiar. So we're going to start off with a difference that we observed, in our case 8%. We're going to go up, we're going to go down by a margin of error, which is the critical z-star times the standard error. All right, it's a really easy process, but it does involve 4 steps. Step 1, same 4 steps we've saw before as well. Step 1 is to name the test in context of what you're looking for. So the name of this test is a 2-sample z-interval for a difference between population proportions. Kind of a long name, yes, but you do need to know that name. It's a 2-sample z-interval for a difference between 2 population proportions. Keep in mind, anytime you're looking at 2 samples, you only care about one thing, the difference between them. All right, step 2 is you do have to check the 3 conditions for the sampling distribution of the differences between 2 population proportions for both samples. So even though we literally cannot make the sampling distributions since we don't know the true proportions, we can build the idea of one in our minds, and that's the idea. It really is. We need to understand that it does exist. So we do have to check those 3 conditions for both samples, and we'll review that here in a moment. All right, then you're going to build the interval, which is what I showed you earlier. It's simply the formula right here to build the interval. That actually takes the least amount of writing. It's really just math. And then finally, we have to interpret the interval. I'm 95% confident that, and then you run with it. So let's go back to our original problem asking, hey, what is the difference between the proportion of teenage girls that do their homework and teenage boys that do their homework every night? And let's run through all 4 steps. This is really simple, guys. I think you're going to catch on to this really quickly. All right, so step 1 is to name it and be specific on what it is you're looking for. So this is a 2-sample z-interval for the difference between the proportion of girls and boys that do their homework every night. That is going to be in the problem. All you got to do is rewrite it, okay? Don't just say, I'm going to find an interval for the difference. You need to be specific as to what that difference you're looking for is. All right, step 2 is really kind of the most boring one because you got to write all the conditions. But both, B-O-T-H, both samples of girls and boys were selected randomly to avoid bias. The sample of 230 teenage girls is under 10% of all teenage girls, and the sample of 250 boys is under 10% of all teenage boys to assume independence. A lot of kids want to get lazy and just say both samples are under 10%, but each sample is from its own population, so you really do have to write this twice. The girls are under 10% of all girls, the boys are under 10% of all boys. All right, finally, each sample does have to have 10 or more successes and failures, doing their homework, not doing their homework. So if you remember from the girls, 184 did their homework. That means 46 did not. That's just the remainder of the 230 girls. For the boys, 180 did their homework, and the remainder would be the 70 that did not. Hence, both of those numbers are greater than 10. So, or actually, all 4 of those numbers are greater than 10. So the sampling distribution will be approximately normal. All right, step 3 is literally my favorite. So I'm going to start off with the formula, and I'm going to just plug everything in. Now, please keep in mind that we're not going to use 1s and 2s. We're going to use G's and B's for boys and girls, okay? That is important to remember because you do want to kind of personalize your problem. You don't just want to stick with, generic numbers, okay? So I just realized that I kind of wrote all that wrong real quick here. I'm so sorry. I was talking and writing at the same time. All right, so 1 is going to be my girls. So this is the proportion of girls that did their homework, 80%. This is the proportion of girls that did not do their homework, 20%. This is the proportion of boys that did their homework, 72%. And this is the proportion of boys that did not do their homework, 28%. Make sure you divide by the proper sample sizes. It's very easy to get these mixed up. 230 girls, so that goes under the girl numbers. 250 boys, that goes under the boy numbers. All right, let's talk about my Z star real quick. I did ask to be 95% confident, so that's that Z star of 1.9600. It is rounded to 4 decimals. And then remember, this is one number, but you need 2 numbers to get the difference. So it's 80% minus 72%. 80% was for the girls, 72% was for the boys. That's a difference of 8%. So my sample was 8%. But again, could be higher, could be lower. That's why we're adding and subtracting the margin of error. So when I calculate margin of error, I typically like to do this in one big swoop. Take the 1.96, multiply it by this. You really don't need parentheses. You can just do a square root. 0.8 times 0.2 divided by 230 plus 0.72 times 0.28 divided by 250. Calculator will take care of order of operations. Just make sure that only that back part is in the square root, not the 1.96. And that gives you the margin of error, 0.0760. So I took 0.08 and I added 0.0760, and that's how I got the 0.156. And then I took 0.08 and I subtracted 0.0760, and that's how I got the 0.004. Okay, now that I got my interval, it is time to interpret it. Now, there are 2 ways to interpret it, and I'll explain both of them. You don't have to have both of them. You only need one, but I'll talk to you about the one that I like better. All right, so one more time, looking at my interval, if I want it to be percentage-based, all you got to do is move the decimal twice. So that's 0.4% and 15.6%. So one conclusion is I'm 95% confident that the difference between the proportion of teenage girls that do their homework each night and the proportion of teenage boys that do their homework each night is between 0.4% and 15.6%. Pretty generic answer there. It does have context because we're talking about the proportion of boys and girls that do their homework. I start off with I'm 95% confident that the difference, remember this whole thing is about looking for the difference, so I'm 95% confident that the difference between the girls and the boys that do their homework each night is somewhere between 0.4% and 15.6%. But I like this next one better. Remember, we were looking at the girls minus the boys. And that order is actually really, really important. Now, my entire interval was positive, 0.004 to 0.156. Now, I did this in an order where I did my girls first, and then I subtracted the boys. So the fact that my entire interval is positive means that I'm fairly confident that the girls is larger than the boys. The question becomes how much larger, and that's this next wording. I'm 95% confident the proportion of teenage girls that do their homework every night is anywhere from 0.4% higher to 15.6% higher than the proportion of teenage boys that do their homework every night. So this is just a different way of wording it that might actually make more sense. Because remember, the whole thing was, hey, what's the difference? Well, this is a lot more an intelligent interpretation. I'm basically saying, hey, listen, at the end of this, I have found out that I'm 95% confident that the girls are going to be more than the boys. How much more is the question? 0.4% higher or anywhere up to 15.6% higher? But it does appear, with 95% confident, that the girls that do their homework every night, the proportion of girls that do their homework every night, is going to be more. All right, guys, that's it. It's really that simple. It's not overly complicated. I am going to run through one more example really quickly with you, just that way you could see how the 4 steps fall into just another example, okay? So if you want to end the video now, feel free. But listen, I'm going to do one more example, and seeing another example is always a good thing. All right. Unemployment rates. An economist wants to know the difference between the proportion of adults that are unemployed in California versus the proportion of adults that are unemployed in Pennsylvania. So a random sample of 825 adults from California showed 3.2% unemployed. Random sample of 900 adults from Pennsylvania showed 2.8% unemployed. Construct a 99% confidence interval for the true difference. Now, I'm just a positive person, so I like to keep things in a positive format. So I'm going to look at this sample from California. Well, that's a G. Still thinking girls here. That's a sample from California minus this sample from Pennsylvania, because that will produce a positive difference. So the California was 0.32% or 0.032 minus Pennsylvania was 0.028. You could do it in the other order. By all means, you're just going to get a negative number, and I like to have a positive number. So I'm going to look at this as California minus Pennsylvania. That order really does matter. All right. Step 1, I'm going to do a 2-sample Z interval for the difference between the proportion of California adults and Pennsylvania adults that are unemployed. I know that writing that is not the most fun thing to do, but it's very necessary. It is the first step. Please make sure you do that. All right, step 2 is really just running through all those conditions. Yes, this is probably one of the most time-consuming parts of any test because your hand's going to get a little bit sore. But you got to make sure you run through all these. And it is a little bit worse when there's 2 samples because you got to check everything twice. But really, please make sure you take the time to maybe pause this video if you need to, read through these conditions and really understand them. But they are needed, even though I literally cannot build the sampling distribution because I don't know the true proportions. It does exist, and that's important to understand. All right, step 3 is literally building the interval. This is what seems to be everybody's favorite step because it is so easy. So I'm looking at California minus Pennsylvania. So my sample from California was 0.032. Sample from Pennsylvania was 0.028. So my difference was 0.004. Very small difference, 0.4% difference. All right. Then I need my margin of error. So my Z stars first for 99% confident, that's 2.5758. Remember, 99% confident means 1% significant. That's a 0.5% at the bottom. So if you do an invert norm of a 0.5%, you'll get the 2.5758. And here comes my standard DV. Standard error, because I'm using my sample proportions. Here's California, unemployed versus employed. Here's Pennsylvania, unemployed versus employed. And then make sure those sample sizes match up properly. Take the 2.5758, multiply it by that standard error, and you get this back part here, the margin of error. So I added it to get 0.0252, subtracted it to get negative 0.0172. Now this is actually really important because I do have a negative on the left and a positive on the right, and that's actually going to be really important. So back to my interpretation. Now, I have 2 of them here. You only need 1. I don't really care, but I do like the bottom one a little better. All right, I'm 99% confident that the difference between the proportion of California adults that are unemployed and Pennsylvania adults that are unemployed is somewhere between negative 1.72% and 2.52%. But again, it's super important that you get the fact that we did California minus Pennsylvania, because that order matters. And it makes a little bit more sense if we word it like this. I'm 99% confident that the proportion of California adults that are unemployed is anywhere from 2.52% higher. Remember, that was the positive end of the interval, which would show that California is 2.52% higher to 1.72% lower. Remember, what does a negative mean? A negative difference would mean that the Pennsylvania is bigger and California is lower. So again, that's why it's important to say, all right, this interval actually teaches me that California could be 2.52% higher. That's on the positive end. Or California could actually be 1.72% lower. So California could be higher or Pennsylvania could be higher because that's what my interval shows. But you know what else? Zero. Zero is in my interval. The fact that one side's negative and one side's positive means that because zero's in my interval, there very easily could be no difference. Now, I don't know that for sure. I'm just pointing out the fact that zero does fall in my interval. So maybe there is no difference between the two unemployment rates. But at the end of the day, I still have no idea what the difference is. I just know that California could be anywhere from 2.52% higher to 1.72% lower. So it's really important when you do get a positive and a negative that you understand what that means for your two populations. All right, guys, that's it. I really, truly hope you find this very easy. It really does come down to 4 steps that are truly not that difficult. They just take a little bit of time to do. But if you truly understand the process and appreciate the process, it's, worthwhile, motivating maybe to go through. All right, see you in the next video. Hope everything made sense.